Okay, so let's write a new heading: increasing and decreasing functions. Okay, a function is increasing if the x values, increase while the y values are also increasing. Okay. So if x values are increasing, whilst the y values are also increasing, then you can say that the function is an increasing function. Okay? Now I want you to know that generally defining an increasing function is based on the y values, because we know that the x values are the inputs, so they will never decrease. Okay, the x values will never decrease. It is the y values that decrease. Okay, so if you see that if you are given a graph and you see that the y values are increasing, that should be a clue to you that okay, the function is increasing. Okay, we don't worry much about the x values because we know that that's the input, so it has to increase. But the output can increase or decrease. If the output, which are the y values, are decreasing, then we have an increasing function. Like for example, if I give you a straight line, a graph, okay, generally you need to have a graph for you to see that the function is increasing or decreasing. So if I draw a straight line like this, it's an increasing function. Because remember, our x values will start from the negatives or the smallest. So as x values increase, going to my right, the y values are increasing. Okay? So that's an increasing function. So this one here is increasing. Okay? And then if I draw a quadratic function, say like that. Okay? This function is not increasing throughout and it's not decreasing throughout. But to the left of the turning point, it is increasing because as x increases, the values of y are increasing until they become stationary here, means they stop increasing here, then they start to decrease. So, to the left of the turning point, the graph is increasing. Okay, so it's an increasing function to the left of the turning point. Sorry? I can't hear you properly. You're talking about the straight line. Yeah. Okay, before we move on, before I answer you, I say the function is increasing if the x values increase while the y values are increasing. The x values will always increase. What do you mean? We are saying they start from the negative towards the what? The positive. Okay? Our y values start from where? They start from the bottom because that's where the minimum is going up. So you can see that the graph is going up. It means y is what? Is increasing. And x starts from the left. X is what? Is increasing. But we judge the graph based on the y values because the x values will always increase, whether a function is an increasing function or it's a decreasing function. So you must look at the y. Are the y values increasing? Are they decreasing? Okay? If the y values are increasing, then you say it's an increasing what? Increasing function. Don't forget that this is the origin. Okay? This is the origin. To the left of the origin, x is negative. To the bottom of the origin, y is what? Negative. So where does y start? Y starts from the bottom. Okay? Start from the bottom. It goes what? Up. Now because the y values are starting from the bottom, they are increasing. You don't start from here, please. You start from the bottom. Okay? Right. Then decreasing function. So if the function is decreasing, if the x values are increasing, while the y values are decreasing. Okay? Remember what I said earlier? The x values will always be increasing because they are the input values. Okay? So it is the output which determines whether the graph of the function is increasing or not. Okay? The y values that determine whether the function is increasing or not. So if the y values are decreasing, then you must know that, okay, my function is a decreasing function. Okay, don't worry about the x values. Okay, so example, if I take a straight line which has got a negative gradient, okay, just to give you extra information, right? If a function has a negative gradient, then it's a decreasing function. If a function has a positive gradient, then it's an increasing function. Okay, just to give you extra information. So this straight line which has a negative gradient it is slanting to the left. Okay? So as the x values increase, the y values, okay? Remember the y values, when we are talking about the y values, we start from the left. Okay? So in this case now, we start from here. Okay? We start from the top because that point there is to the left. Okay? So our x values, as they are increasing, the y values are decreasing. Okay? The x values will always increase, but y is decreasing. Our reference are the input values. Okay? And our input values, we identify them from the left, not from the right. So we start with the x value here. As the x values increase, okay, the y values will be decreased. So this is a decreasing function. Okay? Then, if you have a quadratic one, with a minimum turning point, we are starting from the left. Okay, start from the left here. As x increases, the y values are decreasing until they get to this point where you get the minimum value of y. So to the left, the graph is decreasing. And to the right, it is what? It is increasing. Okay? To the right, it is increasing. From here, as x values increase, the y values are now increasing. Okay? So always check your y values. If the y values are increasing, then it's an increasing function. If the y values are decreasing, then it's a decreasing function. Okay? And you need to know increasing and decreasing functions are geometric. Right? Right. Let's move on to transformation. Right. Transformation is, I'm only going to talk about it because it's a recap of grade 9. Okay? It's a recap. So I'm not going to teach it like from scratch because we don't teach transformation from scratch in grade 10. Okay? It is prior knowledge that you are supposed to have. I need to get on. You can leave some space and catch up later. Okay. So let's talk about transformation. Let's start with translation. Okay. Translation number 1. I'll say to the right. Okay. Okay. To the right, that's positive. So we add. Okay. Like for example, if I say point X is translated by say K units to the right, is our translation rule. Okay, our translation rule, we are starting from X. Okay, let me call this one XY. If you translate it by K units, the new point will end up becoming X plus KY. Okay, right? So we are translating the X value to the right. The Y value remains at the same position. Okay, it's only the Y which changes from X to X plus K. Right? So that's an example. Then number 2, to the left. Negative. So we subtract. Okay. Now a translation to the left, we are talking about X here. Remember, when you're talking about left or right, we are talking about X. Left or right is dealing with X, forget about Y. Okay? So the translation rule, it will be X first. Okay, your point is that when it's translated to the left, the rule is going to be X minus K, but the Y remains at the same position. The y does not change when you are dealing with horizontal translation. Okay, we actually call these two horizontal translation. Okay, then number 3. Okay. So here I'll say upwards. Now when it's upwards, that's positive. So we add. And we are now dealing with y. We are now in the vertical direction. So forget about x. So your rule, it will be xy. Okay, that point, it is moved by k units upwards. So you end up having x, and then you have y plus k. Okay, did this last two. Then downwards, that's negative. Okay, so we subtract. So if you have a point xy, you translate it by k units downwards, you end up getting a new point x, but y is going to be y minus k. And this is the one that I used, and this is the one that I used for that question, because it was a downward translation. So I subtracted, okay? I subtracted. The other thing that's also important, because in this grade you are dealing with functions now, right? When you see f of x, it's y. When you see g of x, it's y. When you see h of x, it's y. All of them, they're equal to y. So where I have got y here, I can substitute any of these f of x. Okay?
There's only those letters.
You can even have m, you can have t, any letter, as long as there is a letter and the x is in brackets. That's called function notation. As long as a letter and then there's x in brackets, means you are dealing with function notation. All right? So make sure you know this. Okay, from now on. Okay, let's move on to reflection. Reflection. Now there are two types of reflection when you are dealing with functions. There is reflection about the x-axis and there is reflection about the y-axis. Okay, so let's start with reflection about the x-axis. Reflection. Okay, let me just write about. Okay, number 1, about the x-axis. Okay. Now this one, if you have a point xy, okay, if you have a point xy, right? Let me just draw a sketch for you. If I have a point, say we call this the first quadrant, right? If I have a point here where I know the x and y are, if I reflect it above the x-axis, this point moves to the what's called the fourth quadrant. Okay? It moves to a point which is below the x-axis. Okay? What does that mean now? The x value still remains the same. The x value doesn't change. Reflection about the x-axis does not change the x value, but it changes the y value. So the root, it will be xy, okay? But the y changes from being positive to negative or vice versa. Okay? Let's say if a point was here, if you reflect about the x-axis, okay? Remember, the x remains the same, but the y changes. At this point here, y is negative. If you reflect about the x-axis, it will get to that point, and the y becomes what? Positive. So the rule for this, it will be x minus 1. Okay? If we use function notation, okay, if you use function notation, let's say our function was f of x, right? Sometimes they may ask you what is the new function, the equation of the new function. If you use this rule, it will be x. You start with x, say f of x. Remember, f of x is y. So I'm replacing the y by what? By f of x, right? Your rule will become x minus f of x. We are just replacing the y by f of x. Okay? Then reflection about the y-axis. Now your reflection about the y-axis is like this. You start with your xy, which is your specific point. You reflect it about the y-axis, which means you are going to end up having something like this. The point is here, you reflect about x-axis, it will be there. Okay? Now what does this mean? It means the y does not change. The y value does not change, but the x value changes. Okay? So your new rule is going to be minus x, y. Okay? If we use function notation, this one here is a little bit tricky as compared to the first one, because we are not dealing with y anymore. And we know that our function notation is for y. So the new rule for this one here, it's wiser to work with it as it is. Okay? But we can also introduce function notation, but I don't want to confuse you now. Okay, for reflection about the y-axis, I'll stop here. Okay, when I do a question, then that's when I need to talk about that aspect. Right? I don't want to introduce the rule using function notation for reflection about the y-axis, because it might confuse you a little bit. Okay, so I'll talk about it when we do question, because it requires two different notations of functions. So I don't want to confuse you there. Okay, so these are some of the key things that you need to be aware of. Right? I'm taking my time to teach the quadratic function because it's a very important function. So we are still going to carry on with the quadratic function. Now the good thing is all these concepts, they apply to a straight line, they apply to all the other new functions that we are going to talk about, including the quadratic. The concept of transformation is the same for all of them. Okay? All right. Then, but we have got a question?